Welcome back to the deep dive. Today, we're going to be looking at moderator variables.
Oh, cool.
Yeah, it's going to be pretty interesting. We're going to be focusing on this paper by Guinness,
Okay.
Boyk, and Pierce, and they talk about this problem that researchers face when they're looking at these moderators.
Yeah.
So
Interesting.
this statistical method called moderated multiple regression, or MMR,
Right.
tends to have this problem of low statistical power.
Yeah, it's like if you were trying to study nocturnal animals, but you could only use like a dim candle.
Oh.
There's all this fascinating stuff happening, but you just can't see it.
Right. You don't have the tools to actually capture it.
Exactly.
Oh, that's interesting. So we could be missing crucial insights because our statistical tools just aren't good enough.
Yeah, and if a study has low power, it might not even pick up on real effects.
Oh, wow.
And then that leads to misleading conclusions.
So it might look like there's no relationship when there actually is one.
Exactly.
We just didn't have the right tools. That makes sense. So this paper, though, offers this new approach to approximating the power of MMR.
Yeah.
So researchers can design studies that are more likely to actually find those
Right.
hidden gems.
Yeah.
So MMR, it's a powerful tool,
Mm-hmm.
but it has this weakness of being underpowered.
Yeah.
So what makes it so weak?
So there's a couple things, but one of the big ones is sample size.
Okay.
If you have a really small sample, it's kind of like trying to find one specific grain of sand on a huge beach.
Okay.
It's just going to get lost, right?
Right.
The effect, even if it's there, it's just going to get lost in everything else.
So size matters.
Yeah.
At least when we're talking about samples.
Right.
What else?
Measurement error.
Oh, okay.
Huge one. Like imagine trying to bake a cake, but you're using like rancid butter.
Yeah.
It doesn't matter how closely you follow the recipe, it's not going to be good.
Right.
Same thing with measurement, If our tools are flawed, even if we have a huge sample size, it won't matter.
Bad data in, bad data out.
Exactly.
What else?
Restriction of range.
Okay.
This is when we limit the variability of like our predictor variable. It's like trying to figure out how well a fish can swim if you only put it in a tiny tank.
Right.
You're not really giving it the space to show you what it can do.
So if we restrict the range of what we're looking at, we might miss an interaction that we would see if we had a wider range.
Exactly.
Got it. Anything else?
Unequal sample sizes can also be a problem if we're comparing two groups, but one of them is way bigger than the other one. It's kind of like comparing apples to oranges.
Right. So like if you're trying to see how well this new teaching method works,
Right.
and you're comparing two schools,
Yeah.
but one school has 100 students and the other one has 20,
Exactly.
it's not a fair comparison.
Yeah, the smaller group might not be representative enough.
Right.
So it's hard to really know if it's the teaching method or just something about that group of students.
That makes sense.
Yeah.
So those are some of the things that contribute to this problem of low power. But luckily, Guinness, Boyk, and Pierce have come up with a solution.
They have.
They have.
Yes. And their solution is really interesting. It's this theory-based approach.
Okay, so how is that different from what's been done before?
So before, people were mostly using simulations,
Okay.
which can be helpful, but they're kind of limited.
In what way?
Well, they only really work well for the specific scenarios that they were designed for.
Okay.
So if your study is a little different, the power estimates might not be accurate.
So this new approach is more flexible.
Yeah, exactly. It's more adaptable, and it can handle those messy, real-world research situations.
Okay, so it could deal with measurement errors.
Yes.
And complex sampling restrictions.
Right.
And even moderators with more than 2 levels.
Exactly.
So instead of just male or female, we could look at like different ethnicities.
Right.
That's cool. So it really opens up a lot of possibilities for research questions.
Yeah, definitely.
So this sounds like a game changer.
I think so.
And to make things even better, they've created this user-friendly program that uses this new approach.
Yeah, it's called MMR.
MMR.
Yeah.
And it helps researchers get accurate power estimates for their studies.
Right.
So instead of just hoping for the best, they can actually plan for statistical power.
Exactly. It's like having a roadmap that helps you avoid all those statistical pitfalls.
I like that analogy. So tell me, how would a researcher actually use this?
Okay, so let's say you're studying a new employee training program.
Okay.
And you think that maybe prior work experience might influence how effective the program is.
Makes sense. Some people might benefit more than others depending on their background.
Right.
Okay.
So with MR power, you would put in things like your sample size,
Okay.
the reliability of your measures, and any restrictions of range, like maybe you're only looking at employees from one specific department.
Okay, so we're taking all those real-world factors into account.
Exactly.
And then what?
Then MR power gives you a power estimate for your study.
So you can see right away if your study is likely to find that moderator effect you're looking for.
Yes. And if the power is too low,
Then what?
then you can make changes to your study design before you even collect any data.
Oh, that's great. So you can fix problems before they even happen.
Right. You might decide to get a bigger sample size or find better measures or maybe even narrow down your study to a specific group.
So it's all about being proactive and making sure your study is as strong as it can be.
Exactly.
It's like having a crystal ball that helps you avoid research disasters.
I like that.
But, this isn't just important for researchers.
That's true.
This idea of statistical power is something we should all be aware of.
Yeah, because we're constantly bombarded with research findings and statistics.
Right, it's everywhere you look.
And if we know that a lot of studies might be underpowered, it changes how we interpret those findings.
So we should always be a little bit skeptical.
Yes.
And ask ourselves, did this study really have the power to find what it was looking for?
Yeah. Right, because a study that says no link between two things,
Okay.
that might not be the whole story.
It might just be that the study was too weak to find the link.
Exactly.
So understanding statistical power is really empowering for all of us.
I agree.
It helps us be more critical of the information we're given.
It encourages us to ask the right questions.
About sample sizes and measurement tools and all those things.
Right, because in the end, it's about making better decisions.
Based on good evidence.
Yes.
Yeah, so it's not just about being a good researcher, it's about being a smart consumer of information.
Right, exactly.
Because these findings are everywhere we look.
They are.
And we have to know how to interpret them.
Especially with so many important decisions riding on them.
Like healthcare decisions or financial decisions or even political decisions. All of that.
So it's about more than just reading a headline and taking it at face value.
Right. We have to dig a little deeper.
Ask the right questions. Exactly like, how big was their sample size? Were their measures reliable? Did they account for all the different factors that could be influencing the results?
Because a study can sound really convincing on the surface.
Yeah, but if it wasn't designed properly,
the conclusions might be totally off.
And that's why understanding statistical power is so important.
It's like having this extra lens that helps us see the world more clearly.
I like that.
It helps us separate the good information from the bad.
And make more informed decisions.
So to wrap things up today, we've been talking about moderator variables.
Those sneaky little things that can change everything.
We talked about MMR and how it's often used to study these moderators.
But also how it can be underpowered.
And then we learned about this new theory-based approach and this tool called ML Power.
Which can help researchers do better.
Plan more effective studies.
Get more reliable results.
And ultimately contribute to a better understanding of the world.
Exactly.
So the next time you come across some research finding that makes you think twice,
remember to ask yourself, did they have the power to really know?
That's all for this deep dive into the fascinating world of moderator variables and statistical power.
Thanks for having me.
Until next time, stay curious.